Hello dear students, welcome back to Learn Physics. In today's video, we will be discussing about this. First itself, I am telling you about this questions which we are discussing today. Usually you will be telling me about that you are not able to write down the questions when I am reading it out. So I thought today I'll be showing the questions like this. For doing this one, see here in this Newton's laws of motion, in that first we need to know about to draw the free body diagram. For drawing the free body diagram, we should know about the different types of forces which is acting on these the objects, okay, at different points, which and all forces will be acting. For that, here I'm first drawing one rigid support. A ladder is here on the rigid support on the wall and the ground. Okay, so here at the ground, obviously mg will be acting downward direction. A normal reactional force will be acting at this point, and here it is touching at this point. Here a normal reactional force will be acting at this point also. Okay, these two reactional forces which is acting on the two surfaces, two sides, this will be perpendicular to each other. Okay, that is an important relation. Now, last class we were telling about the what is that tension and tension which is acting on the massless, frictionless pulley, right? Pulley is massless and the string is massless. How the forces will be acting? So for the same case, I am considering a rigid support here, and here more than one pulley if I am considering. See here, object A is placed over here. Here another pulley A is P1 I am representing. Here I am at the end of this pulley, that is through a string. This is connected to the pulley P1, and the other end of the string is attached to another pulley, that is P2. And from here we are an object is here. Through from this we are keeping one object which is downward B, and here it is attached to another fixed support here. This is a fixed support. So which and all forces will be acting on this device, on this system? Which and all forces will be acting? Obviously, A will be acting a force towards the pulley. Tension will be acting from A to pulley towards T. The T1 is the force which is acting towards or P1. And P1 will be giving a reactional force towards A, that is T2. Now I am considering for this side, okay, P1 to P2. So P1 will be giving a force in the downward direction, that is T towards P2, that is T3, and P2 will be giving a reactional force, that is T4. Okay, now for this B, what will happen here from towards P, which and all forces will be acting? See, a force T3 is acting, P1 is acting a force T1 to this object. Okay, for that a reactional force will be there, right? A reactional force will be there, that is T4. Now for B, mg will be, that is anyway a force will be acting downward direction, that is I am representing it as T5, that will be giving an opposite force, reactional force, which I am representing as T6. For the rigid support, this rigid support will be giving a force T6 in the downward direction. So T6 we already wrote. Okay, T7 in the downward direction and an upward force, reactional force T8. So everywhere you can see one action and reaction. That is, a force will be acting towards P1 and P1 will be giving a reactional force. In all these cases we can see. Okay, here in this case, if string and pulley both are massless and frictionless, both are massless and frictionless. If we are considering so, then what about the tension which is acting on this? See, this T1, T2, T3, T4, T7, T8. All these tensions will be same. Because if it is a massless frictionless pulley, then the tension acting, we last class we learned it as acceleration will remain same for these all these forces, right? That is, tension will remain same if it is massless frictionless. Acceleration will be same if it is an inextensible string, then magnitude of acceleration will be remaining same. If it is frictionless massless pulley, tension will be remaining same. So all these tensions, that is T1, T2, T3, T4, T7, T8, all these will remain same. But what about this T5 and T6? T5 and T6 will be, they will be same. They are not equal to the other forces because the forces acting towards the object. Okay, so on these forces T1, T2, T3, T4, T7, T8, these will remain same if we are considering a massless frictionless pulley. Okay, clear? So next we are going to study about the forces which is acting, different forces which is acting on these devices. Okay, so here which and all forces we can free body diagram. Next about free body diagram. How we can draw a free body diagram means usually FBD, they will be in all the cases we will be using FBD, free body diagram. For that, see where the object is in contact with the ground, those forces and all we will be representing there. Suppose I am taking an object here which is on the ground. Okay, so which and all forces will be acting over here? Mg will be acting downward direction and the reactional force will be acting in the opposite direction. Normal reactional force in the opposite direction. Next, I am going to consider an surface like this, and here on the surface, that is a groove is there. On this surface, a ball is kept like this. Okay, a ball is here on the surface. Well, how will we draw the forces which is acting on here? We know mg will be acting exactly downwards. Mg will be acting downward direction. So the weight mg will be acting downward direction, and here a reactional force will be acting. So mg, a reactional force, in which direction it will be acting? The position where it is in touch with ground. So a reactional force will be acting over here and another reactional force will be acting over here. That is not mandatory that both should be same. It is N1 and N2. These are the normal reactional force which is acting between the surface and this V-shaped groove. Okay, these two normal reactional forces are acting on this system. Okay, so next I am going to consider for, see the next one I am going to consider for this. Here I am taking three objects. Okay, three blocks, I am keeping it like this. Here one and here another one, and this here the top surface another one. This one A, here it is B, and here it is C. Which are the forces which is acting on? First I am considering for A. While I am considering A will be getting a mg downward direction. A reactional force will be acting in the upward direction. Reactional force, from where it will be coming? It will be getting from B. So mg is acting downwards. So this force from B, a reactional force is coming towards A. Okay, it is coming from B. Next I am considering for the surface B. Okay, next is for B. So from B, a reactional force is acting towards A, and then this mg is acting, mg force is acting downward direction. Okay, so force will be, or mg of mass of B into G, this here it is mass of A into G. Okay, weight will be acting, and here and we know a C is here, right? So from C it will be a reactional force will be acting towards what is that, C, right? So a reactional force will be acting towards C from B, acting towards B from C. So this is acting towards B only. I am representing it as NB. Now what about C? C will be giving an mg m of C into G, that weight will be there, and this is giving a force which we represented here. From C only it is giving towards B, right? So NB which is acting over here, and this is the force which is acting, and mg is acting downward direction. So for that a reactional force will be acting towards C. So these are the forces which is acting on A. So while we are considering A, mg is acting downwards. A reactional force that mg is acting downwards, that is acting on B. Because of that, a force is acting towards A. Reactional force is given by B towards A. And when we are considering B will be giving the reactional force towards A. These two are same, right? And mg will be acting downwards, and C will be giving a reactional force towards B. That one I am representing it as BNB. So from while we are considering C is giving a reactional force towards B. So NB, and here we are giving a reactional force from the earth towards the C. Okay, these are the different kinds of forces which is acting on the object. Okay, next is, see here, if I am considering, excuse me, so next is, I am considering a block which is attached to a string, attached to two strings. Okay, here one block is attached to one string from the rigid support, and here another block is another string is attached with another the same block to the other uh, rigid support. This is making an angle theta. So which and all forces will be acting through the string means we will be representing that with a tension. So when we are pulling, see here, if here it is attached to with this string which is making an angle theta. So here it will be acting towards this rigid support, as well as this another tension will be acting towards this rigid support T2, and along with that mg is acting downwards. The reactional force of mg is acting between these two rigid supports. This is making an angle theta. Okay, these are the forces which is acting on the given object. Okay, so mg is acting downward direction. For that, the reactional forces will be acting through this string as T1 and T2. These are the representation. Okay, so now we will see how to represent, how we will be finding out this. So anyway, I'll mark it over here. Okay, so this is the questions which I am giving over here. Okay, you can read, I guess. The diagram shows a rough plank resting on a cylinder with one end of the plank on the rough ground. Neglect the friction between the plank and the cylinder. Draw the diagrams to show forces acting on the plank. First, we need to draw the diagrams for the force acting on the plank. On the plank, which and all forces will be acting. Okay, how can we draw? See, here you can see the plank is here, and it is in touch with the cylinder, right? This is in touch with the cylinder. The cylinder is kept here, and these two are like this, it's written. Okay, so mg, we know that mg will be acting in the downward direction, right? Mg will be acting downward direction, and where and all it is in touch with the surface, there and all forces will be acting. So I am considering the plank separately. So here is the position where what is that, the cylinder is in touch. So when we are considering this plank will be having a weight which will be acting downward direction. Mg will be acting downwards, a mass of the plank into G. And Here it is in touch with the cylinder. So a reactional force will be acting from the cylinder here, N1. Okay, normal reactional force will be acting from the cylinder towards the plank. So N1 is acting upward direction. Okay, now it is in touch with this ground, right? Since it is in touch with the ground, from there a down upward reactional force will be there, because it is mg is acting downwards. So to the reaction of mg will be acting through N3. Okay, these are the forces which we are considering. Next, we are considering about the cylinder. When we are considering the cylinder, this N1 is acting towards the plank. So, same equal and opposite reaction should happen for the cylinder N1 and Mg, which will be acting downwards from the center. And it is in touch with the ground here. So that there also it will be getting a reactional force. I can represent it as N2. Okay, here they are telling it as the force is acting. Neglect the friction between the plank and the cylinder. We should neglect. Now we can so anyway, friction between the plank and the cylinder, when we are neglecting, there will be a friction between the cylinder and the ground. Okay, so between the cylinder and ground, a friction will be there, which will be acting towards, a frictional force will be acting towards the in the opposite direction, and from here also, from plank also, it will be getting a frictional force F1 and F2. So these are the forces which is acting on it. Okay, clear? Should I explain it once more? I'll explain the whole thing once more. Here we will be representing the, first we are representing the plank. The plank will be giving a force mg downward direction. Reactional force will be getting from the ground itself, from the ground towards the plank. This one we can represent. The reactional force, normal reaction, I am representing it as N1, and here it is in touch with the cylinder. There we are getting a what is that? Reactional force, that is N2, which is acting in the upward direction. So we are considering the ground and the plank reactional force, frictional force we are considering. The frictional force is acting like this. And when we are considering the cylinder mg, here is it is in touch with, right? So mg is acting in downward direction. Obviously a reactional force will be acting N3. And N2 is here, from cylinder only N2 is getting, right? So towards the cylinder also N2 will be acting. Okay, so these are the forces which is acting on the plank. Okay, clear? So next is, the two spheres A and B are placed between two vertical walls as shown in the diagram. Friction is absent everywhere. Draw the free body diagram for both the spheres. Okay, so here this is in touch. So anyway, mg will be acting downwards. Those two mg we can represent. Okay, so instead of representing mg, I will represent it as WA, WB. That is more convenient, I guess. Okay, so mg not required, so I'm representing it as WA, WB. Okay, so anyway the reactional force will be there. That one I can represent it as N1 as upward, here N2 I'm representing the reactional force as N2. Now it is in touch with here, right? So N2, and here a force N3 is acting here, and here a force, reactional force will be here, and here N4, N4. These are the two reactional forces which is acting on the object. Okay, and here we will be getting another reactional force. Okay, another reaction, this here also in touch. So from these diagrams and all, what you are understanding, from here where and all it is in touch with the ground or to a rigid support, there and all we will be getting a reactional force. Okay, reactional force, we will be, the total weight mg is acting exactly downwards, that will be exactly balanced with the reactional forces. Okay, so if I'm solving all these questions today, then I think it will be a very lengthy video. So in today's class I'm winding up. In next class we will be discussing the rest of the questions along with this second question. Okay, and you please comment it in the comment box if you're not getting this what are the forces acting on this spheres. Okay, the rest of the question, if you want, you can write down and check whether you are getting it or not. We'll be explaining in the next class. Okay dears, that's all. Thank you.